Good morning, geometry guys. Coming at you on a springtime day. Don't forget to like, subscribe, bell. All right, a polyhedron. If that looks like it's in a different language, it's because it is. It's Greek. Okay. So it's a three-dimensional figure with a pair of congruent parallel faces. Okay, these are called bases. No treble. All right. The other faces are called lateral faces because they are laterally. Kind of crazy. Whoever was naming stuff, they were not very, original. All right. And they're categorized by the name of their bases. Like, this right here, that's why that base is a triangle. That's why it's called a triangular prism. Rectangular, okay, pentagonal, all that kind of stuff. Now, the height, little h, of the prism is a perpendicular distance between the bases. Okay, sometimes the height will be like sideways and stuff like that. We will have some triangular bases later today that we're going to put a pin in until tomorrow, until I can get a better, so to speak, formula for that, because on a few of these today that they're missing measurements and it just doesn't make sense. Okay, all right. So that being said, all right. Now, surface area. All right. Personally, I did this first period. I showed the formula. Personally, I don't really like the formula. Okay, I kind of like this way. I want to show you this way. I'm also going to show you the formula, and it doesn't really matter which way you use as long as you understand what's going on. All right, so if this is the front, okay, this, 5 times 4. All right, how many faces is that? Because we got to count the front and the back. The front and the back. Okay. 2. Okay, the front and the back. Okay, so that would be 5 times 4 is 20 times 2. This would be 40 centimeters squared. Okay. Now, this is the right, and this one that we can't see is the left. Of course, I always loved it when in all my math classes I had to draw a three-dimensional figure on a two-dimensional sheet of paper. Makes zero sense. All right, so that would be, because this is 5 centimeters here, this would be 5 times 3 times 2. All right, 5 times 3 is 15 times 2 is 30 centimeters squared. All right, then we have the top, and somewhere under here we have the bottom. All right, and that's these two measurements. So we could say 4 times 3 times 2. Okay. Well, 4 times 3 is 12 times 2 is 24 centimeters squared. All right. Now, if we add all this up, all right, if we say 40 plus 30 plus 24, all right, this all becomes 94 centimeters squared. All right. Now, 94 centimeters squared. This is the main one, that way I like to do this. To me, it just makes sense. All right. So now I'm going to pause here in a little bit because I'm going to let y'all write this down. All right. So this SA, surface area, is the perimeter of a base times the height plus twice the area of the big B is the area of the base. Okay, that's kind of weird when we start saying big B, little b, this, that, and the other. Okay, but, and then lateral area is just the perimeter times the height. It doesn't matter, okay? Some of this stuff you can get lost in the sauce by, trying to follow, oh, what does this mean? What does this mean? You could do exactly what we just did and get the same answer. It's fine, okay? I just have to show it to you. I don't have to, require you to use it. I may require you to show the setup. That would be easy. But that kind of things. Now, so, look, this is how much I kind of don't like this. I didn't even write it out. I just said I just used what was in the PowerPoint. All right, so I'm going to pause here. All right, now the reason why I don't like this as much is because it talks about bases and faces, and then what if you use the 5 times 4 instead of the 4 times 3 and this, that, and the other. Okay. Maybe I'm just a little old school and I like the old way of doing it and it works for me. Okay. It doesn't matter. You could use this or you could use the other one. You're going to get the same thing. Now, some of this surface area stuff, people are wondering why we need to cover it. Yeah, it's just one of those things for geometry. But in some of these plants around here, if you've ever heard of a outage or a shutdown or something like that, where they close off parts of this plant to like rework stuff, if you're having to repaint something or doing some type of covering, this is actually important. The company that holds one of the patents for the covering for the stealth bomber, they're in Huntsville, and actually they had to use that type of formula for when they're coating these planes to make them undetectable by radar. So this one actually does have a little bit more outside use. All right, a cylinder. Okay, cylinder is like a prism. Okay, so you have two congruent parallel bases that they're circles. Okay. Now, the surface area of a cylinder is, all right, this is the circumference, so it's almost like the circumference times the height plus twice the area. This one's a little bit easier to figure out. It's kind of straightforward. I know in years past, I've seen people, they'll have like a handout thing where you got to cut things out and you got to tape them together. The fact that people just constantly throw trash in the floor and whatever else because they don't want to clean it up. That's because those two ghosts in here, not me and not mine. We're not going to do any type of craft like that because it just wouldn't work. All right, so find the surface area of the cylinder in terms of pi. All right. So my radius I'm going to use for this is going to be 4 inches. All right. My height is going to be 6 inches. All right. So this is going to be 2 times pi times 4 times 6. All right. Now, this part right here is also my lateral area. Okay. So let's see. 4 times 6 is 24 times 2. So this would be 48 pi inches squared. And then the second part, 2 pi 4 squared. Alright, so we would have 48 plus, let's see, 4 squared is 16 times 2 is 32 pi. I forgot the pi on this one. Alright, so we would get 80 pi inches squared. Alright, literally just, this one makes a little bit more sense. Use the formula. The formula for the second one, not a big fan. Alright, so any question? Now, finding this and rounding the nearest tenth, we're not going to do that. We're just going to leave it in terms of pi. It's easier that way. It's actually the preferred method. Okay. Alright. On these problems right here, I don't want you to do number 9. Okay, so mark out number 9. I don't want you to do number 12 right now. Alright. And on the last 3, we're going to leave in terms of pi. Okay, now, originally, going back to the last test, originally I thought about making another practice test for people that's doing a retake or whatever, and I figured they had 2 practice tests, all the stuff online. No. Okay, so if, you know, you can make another orange sheet if needed, but, you know, that's what happens. Alright, so they're going to work on these few problems in class, and we'll come back and check them. Don't forget, hit like, subscribe, the bell. Good stuff, good things. Roll Tide.